with all the interesting technical stuff. So my name is Thorben Janssen. I'm one of the organizers of the Paderborn Java user group. I speak German and English. And if you have any questions, feel free to either unmute yourself and then ask them in German or English, or post them into the chat. At any time you have the question, I will do my best to answer them during the talk or afterwards if you want to ask them after we are done with the main topic. Yeah, I'm not speaking at a Java user group. I'm working as an independent consultant, trainer, author, always focused on Java persistence topics, mostly with JPA and Hibernate. And some of you might know my website, thoughtsonjava.org, which is now thorbenjanssen.com. If you want to dive deeper into any of the topics that we will be talking about tonight, take a look at the website. You will most likely find an article about it. Okay, then before we get into the IDE and take a look at all the pitfalls that we have with Hibernate, I want to make absolutely sure that you can, that we all agree that you can, of course, implement highly efficient Java applications using Hibernate. That's what I'm doing in my day-to-day work. I'm helping teams as a coach or consultant to improve the performance of their persistence layer or to model complex persistence layers. But, well, let's be honest, just talking about best practices and what you should do and what you should not do, that gets a little bit boring over time, right? So why not take a different approach and break a few things and take a look at what you can do really wrong to make sure that your project will fail. Well, and if you don't want to do that in your real project, then maybe pay a little bit more attention to the second part of each issue that I show you, where I explain how to avoid these and do it better. Okay, what are the best ways to actually break a project, make it fail dramatically? Well, very bad performance is always a really good approach to ruin the user experience of your application and to make sure that absolutely nobody wants to use it. So we will take a look at that. Inconsistent results is also something that all of our users love. And data loss is probably the nightmare scenario for all CEOs and managers. So when we are looking for a way to break a project and make it fail, then losing data is definitely a good approach, and we will take a look at that as well. Okay, let's start with bad performance. And not only best practices get boring when we just talk about them, it's the same with slides. So let's get into the IDE and take a look at actual code. The first thing I would expect most of you know about, and that is the lazy initialization exception. So what do I do here? Well, I have a query that gets an author from the database. So in all the examples that we will look at tonight, we're using a basic domain model that could be used in an online bookstore. So we have authors, we have books, we have publishers. Just typical example domain model. So here I'm loading an author, and then I'm closing my entity manager and transaction, and then I'm calling down here the getBooks method on my author entity. That would usually happen in your front end, or maybe in a separate class that generates the JSON document that you provide in your REST API. And here you can see the typical exception, probably all of us know, the lazy initialization exception. That happens when we have a lazily fetched association like the one here that we try to use outside of a transaction. What happens here? Hibernate fetches the author up here, and then because we have a many-to-many association without any additional mapping information, Hibernate doesn't initialize the books association, and when we work with it here, we get the lazy initialization exception. So that's a pretty common thing, and unfortunately, there's lots of bad advice on how to fix it on the internet, even though it's one of the most common issues for the last probably 20 years since the beginning of Hibernate. Because, well, if you Google for how to fix a lazy initialization exception, you will find the suggestion on Stack Overflow and other sites that, well, this would be pretty easy. You just switched your fetch type to eager. Well, technically, that fixes the lazy initialization exception because, right, we no longer have lazy initialization. We are now fetching it eager. And you can see here the test now passed. And if we take a look at the log, then you can see that the query actually looks pretty fine, right? So we select all the columns from the author and from the book, and Hibernate joins from the author to the book author to the book table. The book author table here is the typical many-to-many association table that you have in the relational table model when we model a many-to-many association. So if we just look at this example, then the log looks actually pretty good. We just used one query and we got everything that we needed. We got the author and we got the book information. Great. With one query, a simple query, we would write the query in the same way if we would write it ourselves. But the issue is that this doesn't work for all the queries. Let's say we are not fetching one author using the entity manager find method. Let's say we have a query in our application. This is a very basic one that just fetches all the authors. You can see the test passes. We fetch all the authors, and down here I iterate over the list of authors and write out their first and last names. We now look at our statistics. We see that we have 7 JDBC statements. That are actually quite a lot, considering that we just wrote one query. Why do we have 7 statements? Well, because I just have 6 authors in my database. We have one query that fetches all the authors, and then we have one query, 2, 3, 4, 5, 6 queries that fetch the books for each author. This is a typical N+1 issue. And it doesn't seem like a big thing when we are now looking here at our small test case using a small test database with just 6 authors in it. Let's say we deploy this one to production and we have a few more authors in our database. Let's say 1 million, 10 million, or just a few 100,000. Well, in that case, we would have the same behavior from Hibernate. We would have a query that fetches all the authors, and then we would trigger another query to initialize each of the authors with the book association. So we would have this query for each of the authors, and we could be pretty sure that when we deploy that to production, this test case runs, well, on most systems about 5 minutes, and then it fails. Why 5 minutes? Right, because it's the default transaction timer on most systems. And the sheer number of queries that we will trigger here will just break the whole use case, and we will have a horrible performance. Because we said here on the author entity that we want to fetch the association from the author to the books eagerly. That tells Hibernate to always initialize the books association, even though our test case doesn't use any book information. So yeah, using fetch type eager wasn't a great idea here. If we now switch it back to lazy, which is the default, and take a look at the log, then we see that we now just have one JDBC statement and we just got the author from the database. Much better for this use case. No N+1 select issue, no performance problems. But we still have the lazy initialization exception up here. And well, there's a much better way to fix it. than using the fetch type eager. What we should do here is we keep the fetch type of the association lazy and tell Hibernate, well, if I don't use the association, then please don't get it from the database. But for this specific scenario where we know that we will use the association to the books, we use a left join fetch clause, or you could also use an entity graph. Both of them tell Hibernate to initialize the association when fetching the author from the database. So by adding the left join fetch clause here to the query, you will now see that the test case passed. And if we take a look at the log file, you can see here that we have basically the same query as we had before when we activated the eager fetching for the association. The main difference is that we now control when Hibernate joins the association and fetches the information, and we don't cause any n+1 select issues. So what does the left join fetch do? The left join fetch extends the projection, which means the select clause of the query, to add here the information about the book, and adds the join clause down here. So in contrast to a normal join or left join that just joins the information within the query but doesn't return the information back to the caller, which is our Java application, the join fetch clause that we added here tells Hibernate to use initialize the books association, which means it has to initialize, it has to fetch all the information for the books, which then resides in this extended select clause. Okay, another performance pitfall that can create huge issues with applications after you deploy them to production is modeling many-to-many associations using the wrong data type. So here we have our book entity, and we have a many-to-many association to the authors. And well, if we model a too-many association, most developers would say, well, a list is the most efficient collection type in Java. So it has to be the most efficient approach to use a list when modeling a too-many association. Well, unfortunately not when we're using Hibernate. Because as you will see here, Hibernate handles lists for many-to-many association very inefficiently when you are adding or removing elements from that list. So what I do here is I get a book from the database, and then I just remove the first author from the list of authors who've written that book. So what would you expect when you have something like this in the code? Well, you would probably expect that Hibernate would trigger a delete statement that removes the record from the association table that connects this book with that author. Yeah, no. What Hibernate does is, Hibernate, where's it here? Hibernate removes all the records from the book author table that belong to that book. And then it takes the list of authors and adds a record to the association table for each element in that list. Again, we are working with a small test database here, and luckily the book was only written by 4 authors. Let's say we have something with more elements here with a few thousand. That would mean we first drop all of them or delete them from the association table, and then we have an insert statement for each of them. Well, that looks really strange when you activate auditing for your database, and it would definitely cause some questions if an auditor wants to check what your application does with the database. And it also creates a pretty bad performance because, well, it's obvious that in this case, 7 JDBC statements take way longer than the 2 or 3 that you would normally need if you just remove that specific record from the association. So how can you fix that? the fix is actually pretty easy. We switch from list to set, and then I need to adjust my getter and setter methods down here. And the problem disappears. We now just have one delete statement here, which removes the record from the book author table that belongs to the book and the author for which we want to remove the association. So now we have 4 JDBC statements instead of the 7 that we had before, because we are now not inserting the 3 remaining authors. We just keep the record in the database. And well, sure, the set that we now use here from a Java point of view is a little bit slower than the list. But before you start worrying about that, let's talk about the number of elements that we usually have in such an association. Well, if we want to be able to model it as a many-to-many association and fetch the information from the database, then we probably just have, well, maybe a few dozen. We are probably in the 2-digit, maybe small 3-digit range. Otherwise, it will take really long to fetch all the data from the database to initialize the association. Well, if you compare the performance of a list compared to a set for such a small number of elements, you will actually recognize that it doesn't really make a difference. So yes, the set is a little bit slower than the list, but in this case, only in theory, because you will never have as many elements as you would need to actually see a difference. Because if we are fetching a few million records to actually see a performance difference between a list and a set, then yes, you will have a performance issue, but it will not be caused by the set. It will be caused by the amount of data that you actually fetch from the database. Let me switch this back to a list real quick, because there's another thing I want to show you. Up here, I showed you how to initialize an association to make sure that we don't run into an n+1 select issue. So what if we have multiple associations that we want to initialize? Well, we could then say we do multiple left join fetch clauses. I do that here. I start on the book, left join fetch to the authors, left join fetch to the reviews. Where you already see it, the test case failed, and it failed with a multiple bag fetch exception. Hibernate complains that it can't fetch multiple bags. What is a bag? If we look at the book, I have a list and another list, but no bag. Well, bag is a Hibernate internal construct or type, and it basically means it's an unordered collection of elements. And you always have that if you model your to-many association as a list without defining any ordering on it. And well, then Hibernate calls it a bag, and as we saw here, we can fetch multiple bags within one query. There's again a simple fix to that. You can just go here and switch it to set, which is what we want to do anyways to avoid this inefficient handling of write operations on our association. And then you can run the same test case again. We now see test case passed, and we see here that we now have multiple left outer join clauses and significantly bigger select clause that now fetch the book with all the author information, with all the review information within one query. In this case, you need to need to be a little bit careful with join fetches. So one thing that gets then often discussed is, well, how many left join fetches should you add to a query? Some people say never more than one. I don't like these hard rules, because well, that would mean that an association that contains two elements is treated in the same way as an association that contains 100,000 elements. And it's obvious that that doesn't make any sense. When you're thinking about using multiple left join fetch clauses, and you always need to think about the number of elements that are part of this association. So it most likely doesn't make any problems if you have a left join fetch clause that joins the authors to book. That's probably not the case for reviews, because where the latest bestseller could have several thousand of it, and that would mean that we create a huge product. We would get the book. Well, let's take a look at the query again, and then I will answer the questions from the chat. So what we are doing here is we are creating a product. When you're thinking about how many records we will get back from the database, then we get the book, each book multiplied by the author multiplied by the number of reviews. That's just how a relational database and SQL work, which means you get the book and then the information of the first author, and then the same book with the information of the second author, the same book with the information of the third author, and so on. So if you use multiple join fetch clauses, as I do here, and your associations contain a lot of elements, this product will get huge. And at some point, it will slow down the application. So please be careful about using multiple join fetch clauses, and take a look at the size of the product that you are actually creating here. Okay, let's take a look at the questions in the chat. Devesh asks, I have a general question. Is there any business use case in which Hibernate expects developer to use list for many-to-many associations? If not, why wouldn't Hibernate by default fire just the delete query instead of delete plus insert? And then be fixed in upcoming Hibernate versions. Well, first of all, Eclipse Link handles the many-to-many associations that are modeled as a list way better. They do use the same approach as Hibernate does with a set. The question is, well, is there a reason to actually use lists? Well, there could be. There's a main difference between a list and a set. In a list, you can have multiple identical entries. Don't have that in a set. So that means you could model a too-many association in which you have multiple associations to, but in this case, it would be to the same author. It doesn't make a lot of sense for this bookstore of this bookstore example. But let's just say we would like to be able to add an author multiple times. Where is it? Here, multiple times to the list of authors of a book for whatever reason. Then you wouldn't be able to do that with a set, but you could do that with a list. And if you need to be able to do that, then you need to use a list, and then you need to be aware of this inefficiency. In all other cases, which are probably 99.9% of your of the use cases that you're implementing, I would recommend to always use a set. Well, would that be fixed in upcoming Hibernate versions? Most likely not. The main argument why it's implemented like it is right now is that in a set, you can't have multiple identical records, and you have way stronger requirements for the implementation of an equals method. With a list, you can't really be sure that you have a meaningful implementation of an equals method and that there are not more than one identical elements. So If you say that these things are important, then you can't implement it differently. So that's why I don't expect that it will be fixed. But I'm not part of the Hibernate team. Maybe they decide to change it in the future. I just don't expect it. Michael wrote, what if you need an order in your collection like list? Well, first of all, I would question if you need the order for all of your use cases. If you add it to your entity mapping here, then the ordering would be applied each and every time you fetch the books for a given author. Most likely, you will have a few situations in your application, probably most of them, in which you don't need to get the books when you get, where you don't get a need to get the books in a specific order when you initialize the list of books for an author. So because of that, I would not recommend to add that mapping to add that ordering to the entity mapping. I would recommend to write a query that gets the books in a specific order if you need them. But if you need to, if you're sure that you always need the elements of the association in a specific order, then there's the order by annotation. You can use that one to define an order by clause, which will always be applied to the query when you fetch the element, the association from the database. As I said, most likely it's better to use a query instead of an order by annotation here, because ordering costs time and resources, and you only want to do that if you need it and not just in all cases. So yeah, Andre was completely right with the order by annotation that he mentioned in the chat. Okay, we had a look at this query here where we have multiple join fetch clauses. And we need them because down here we want to print out the title of the book with the names of the authors and the number of reviews. So in that case, you could say, well, I just use multiple join fetch clauses to get the books with the initialized authors, avoid the n+1 select issues that we had before, and well, hopefully don't create an implementation that has a horrible performance. If you want to make sure that your project fails, you just remove this left join fetch part, and you will struggle with the lazy initialization exceptions we talked about and the performance issues if you move that part into your transaction. But there's actually an even better approach than using multiple join fetch clauses if you're just reading some information. In that case, it would be way better to use a DTO projection, which is an unmanaged object. And I created an example for that here. In the previous test case, we wanted to get the title of the book, the name of all authors, and the number of reviews. So there's actually no need to get the full book entity, a list with all author entities, and a list with all reviews. For the review, we just want the number. For the authors, we just want the names, and for the book, only the title. No reason to fetch the text of the review and the cover of the book and all the other information that we store in the database. So you could create a class. In this case, I call it book author review with the title attribute, an author names attribute, and a review count attribute. And well, this is a really basic class, just a few getter and setter, and that's the important thing, a constructor that initializes all attributes. So if you want to use this approach, then you could do a query with a select new and then the fully qualified class name. And then you just put in the elements that you actually want to select. So here I select the title of the book, then I use a database function to join the first name with the last name of each author, and then I count the reviews. And well, then I join here the authors and reviews in the from clause. And take a look at the log. We can see here that we now have all the information that we need in the log message. Up here, we just selected the book, the title of the book. We aggregated the names of the authors, and we counted the number of reviews. You can already see the select clause is much smaller than it was before. We just select the information that we actually need. We don't have any management overhead for our entity objects, because now we are using an unmanaged object. And well, if you use this approach in a real application, you're usually multiple times faster than fetching the graph of entities from the database. Let's take another look at the questions in the chat. Devesh asks, if I fetch books with authors and I have to fetch reviews separately due to performance issues, but I need combined object graph of book authors and book reviews, how do I get that? Okay, what you could do is you could split this into two queries. You could start with a query that gets what was it? That gets the books and authors, and a query that gets the books and reviews. And if you select them as entities, you can benefit from the guarantee that JPA provides you that there's only one entity object within a Hibernate session or any other persistence provider session that represents one record in the database. So Hibernate in that case actually merges the entities together. And in the end, if even so you fetched it in two separate queries, you get fully initialized entity graph with the authors, the books, and the reviews from after you executed the second query. This is actually a pretty common approach if this part here creates a product that's just too big. Then you usually split it up into multiple queries, and because you're working with entities, Hibernate merges them for you. Andre asked, is it a good approach to use projections when use cases for entities grow? For example, if you have a slightly different case where another field or two needed, just add a new projection, just extend current projection and build a hierarchy of them. Well, that depends. So from a performance point of view, it's of course the best approach to use a projection like this one here that exactly fits your use case, that only selects the information that you actually need. And that is what I recommend in general. The issue here is that most teams are not really happy with the number of DTO classes that you then need to decide to create. Let's say we also need we have a second use case that needs the title of the book, the publishing date of the book, the first and last name of the author, and the number of reviews. So the question there is, what do you do? From a performance point of view, the best approach would be to create two classes, the book author review that we have here, and the second one that stores the title and publishing date of the book, the name of the authors, and the number of reviews. But I totally get the issue that you then create lots of DTO classes, and at some point it affects the maintainability of your application. So what you could do in such a situation is you just add an additional attribute here, maybe create a second constructor, or fill it here with a null value, and then reuse the book author review class for both use cases. But please don't start creating a DTO class for each entity class that actually is completely the same, because then we are losing our performance advantages or benefits of this approach, where we are able to create a selection that actually fits our use case. So adding one or two basic attributes of an entity to such a DTO projection might be okay. Having more than 2 or maybe 3 versions of this constructor up here is definitely a code smell. So yeah, take a look at it. Think about it. Does it actually make sense? Would it be something that you want to maintain in the long run? And is it something that is actually usable within your code? Because the next issue would be if you have more attributes here, and some of them initialized and others are not, depending on which method you call in your backend, it will be really hard to work with objects of type book author review, because you never know which attributes are actually initialized. So to summarize that answer, the correct and best approach would be to have one DTO class for a specific selection, and that can and as long as multiple use cases use exactly the same selection, then you can reuse that for all of them. That's totally fine. But as soon as you need additional attributes that are not used by all of these use cases, you should create another DTO class. You can deviate from that approach if you're careful, and maybe add 1 or 2 basic attributes, but I wouldn't add more to that. Then Michael asks, how can you use paging if you neither want to load one or all entities, for example, authors? Well, what you can do is you can do a query A from author A class, and then you can set max results. That is the number of records that will be returned from the query. And so that would be the offset part of your select statement, and set first result. No, the max result is the limit, and the set first result is the offset of your SQS statement. So this one tells you how many records in the result set shall be skipped before the database starts returning the selected records, and this is the number of records you want to fetch. Okay. Then let's take a look at another thing that is a perfect way to break an application. So let's quickly go to the book entity and remove the cacheable annotation here and there. Okay. So are you familiar with the query cache? So Hibernate can cache query results, and that is, well, a two-edged sword. It can be it can be great and improve the performance of your application dramatically, but it also introduces several pitfalls. The first of that is that you not only need to execute a query multiple times in your application, you also need to make sure that you execute it with exactly the same bind parameter values. Otherwise, you don't get any benefits from your query cache. You also need to make sure that you have almost no changes on the database tables that are used in that query. But let's say all of that is the case, and you check that, and you're sure that your query is actually a good fit for your cache. Then there's a great way that you can use to actually increase the number of select statements drastically. So let's take a look at the test case here. I have my first session, which would be the first call onto the backend. And what I do here is I select books with authors and reviews, and I tell Hibernate, okay, I want to cache the result of that query. And down here, I run the exact same query again and also tell Hibernate, yeah, I want to cache that one. So we would now expect that we execute that query, we cache the result, and down here we don't need to go to the database, right? I mean, that's why we are caching the query result. Well, let's take a look. Where's my first session? There it is. So I'm fetching my book with the authors and the reviews, and I get all the information within one JDBC statement, and then I can see here that I've put all that stuff into the database, into the cache. Great. So now I do the same thing again, and well, what's going on here? Queries, lots of queries, even more queries. Doesn't end. Okay, down here we have the session statistics of the second iteration, and we have a crazy number of 36 JDBC statements. But we just executed a query that we cached. So what's happening here? Well, the query cache only caches references to entities. It doesn't cache the entities itself. Our query selects entities, the book entity with an initialized list of authors and reviews. And if you remember what I just did a few seconds ago, I removed the cacheable annotation from the book and from the author, which means that author and book were not cached. They were not stored in our second level cache. And the result of that was that somewhere up here, we got, where is it? Here, between the second iteration log message and that statement here, we got the cached query result, the result of that query here. And that contained references to book, author, and review entities. And then Hibernate checked, okay, can I resolve that book entity reference against the first level cache? Well, no, we just started the session. The first level cache was empty. Can I resolve it against the second level cache? Well, no, because we don't cache book entities. And then, well, we need to go to the database. So Hibernate starts fetching all the book entities. You see it here, always by ID from the database. And it keeps doing that until it got all the books. And then we start initializing the associations. It's going on and on and on and on. And at some point we're done. And that cost 36 JDBC statements. So this is the result of a pretty small but horrible misconfiguration of our persistence layer. When you use the query cache and activate and cache the result of a query that returns entities, please always make sure that, first of all, these entity classes are cached. So we have a cacheable annotation up here. And as a second thing, make sure that your query cache and your second level cache are configured in the same or a compatible way. You need to make sure that your entities stay at least as long in the cache as your query resides. Otherwise, you will run into the situation that we just saw. So after that, we still need to still see here that we now have 24 statements, which is better than 36 that we had before, right? But still more than we would probably expect. The reason for that is that we are now fetching the reviews and the authors for each book. The reason for that is that if we cache the book entity and cache the author entity, then we cache the entities itself. What we don't cache is the association between them. To do that, we need a cache annotation on each of these associations. So I added these annotations, and let's run the test case again. And now we are down to 0 JDBC statements. That is what we expected from the beginning. We expected that we would get all the information from the cache, but we only cached the query result, not the entity objects that were part of it. And if we start caching the entity object, right, first of all, to do that, we need to annotate the entity class with @cacheable. But then we also need to think about the associations between them. In this case, we cache books, we cache authors, but by default, we don't cache the association between them. We can change that by adding a cache annotation to the association attribute. By the way, you can use the query cache also for other queries that don't return entities. You can also use it for queries that return DTO objects. In this case, I'm selecting book author review objects, and as you can see here, second transaction executed 0 statements and got an element from the cache, and the first one executed 1 query and put 1 element in the cache. The query is the one that initializes, or that gets the title, the number, the name of the authors, and the number of reviews from the database. And then Hibernate instantiates a book author review object. And down here, we cache the same query. The interesting part of that is that we now, let me explain that in code. The interesting thing here is that the list of book author review objects that we get up here is a different one than the ones down here. So what Hibernate caches is, Hibernate caches the SQL statement with the result. So these 3 scalar values. And then when we run the second transaction and get the data from the query cache, Hibernate instantiates new book author review objects for each record in the cache for this query result. So you don't need to worry about concurrency issues or stuff like that. Devesh has another question. To create a copy of entire object graph, for example, author, books, reviews, and persist it as a separate database entry. What is the best way to do it? Read using DTO projections and create object graph from DTO projections and then persist in DB, or read entire entity graph from DB and then create a copy of that entity graph with IDs as nulls and then persist, or any other approach? Well, the best approach would probably be to select the entities and then instantiate new entity objects and set all the attributes on these objects. Yeah, you would need to create a copy of each entity object and set all the attribute values on that object, and then persist the new entity object in the database. But in general, I would take another look at the use case and double check if you really need to implement it in that way. Do you really need to create a copy of these objects? Wouldn't it be better to introduce something like an audit log if you just need to, well, if you actually need to create an audit log entry for your data and actually need to document what has changed. That would be the most common reason why teams start to create a copy of a graph of entities, which in almost all cases is a bad idea. If you really have to implement it in that way, then you might also want to take a look at a stored procedure. If it's a huge graph of objects, that would allow you to handle all of that in the database instead of your Java code, which would be way more efficient. Okay. Well, so I made a few suggestions on how you can break your application by creating a really bad performance, right? So you could use eager fetching, for example, to make sure that you trigger lots of queries and n+1 select issues. Or if you want to avoid it, then well, you use fetch type lazy and use case specific fetching and projections. Use case specific fetching would be the join fetch clause that we had a look at the beginning. The use case specific projection would be the DTO class that we talked about. Then you should take a look at the data type that you use to model your many-to-many associations. Sets provide a way better performance than lists. You should also be careful about cascading, especially cascade type remove. It's, well, from a performance point of view, the critical part is that you fetch the each associated object and then use a separate statement to remove it. When we're talking about data loss, then we show you how dramatically cascade type remove might affect the data that you remove from the database. And then you always need to check your cache configuration, especially when you start using the query cache, but also when you're using the second level cache. Caching is always something that requires lots of tests and a good understanding of the data that you have in your production system. Otherwise, the overhead of the cache will most likely be bigger than the actual performance improvement that you get by using the cache. Okay, well, the next thing that you can do to drive your users really mad would be to create inconsistent results. So let's take a look at another few test cases and see what you can actually do to create inconsistent results that just look wrong. But I hope you remember the left join fetch clause we talked about at the beginning of this session tonight. I said that you should use a left join fetch clause to initialize the association, in this case, between the author and the books, if you need an author and or their books. Well, what then quite often happens is, especially in JPQL, then someone says, okay, I want all authors who have written a specific book, and I want them with an initialized list of their books. So they start writing a query that selects authors from the database, They start on the author entity, left join fetch books, and say, well, we don't need all of them. We just need the ones that wrote the book, let's say with the ID 2. So we use the joint books association, the join fetched books association in our where clause. And if you run this test, you see, well, it passes, doesn't cause any issues. And if we take a look at the log, then we see that book 2 was written by, no, that author Max Mustermann wrote book 2 and Maria Mustermann wrote book 2. Looks good, right? Nothing seems to be wrong here. Well, let's change the query and actually use a left join, which we then use in the where clause, and another left join fetch to initialize the books association. And let's take another look at the log output. Then we see that Maria Mustermann wrote not only book 2, she wrote book 2, 3, and 4, and Max wrote book 1, 2, 3. That looks a little bit different than the result that we had just a few seconds ago, where both only wrote book 2. Why is the result different? Well, up here in the first query, we mixed two things together. We used the join fetched association in the where clause to limit our result set to all the records with the book ID 2. And we used the left join fetch to tell Hibernate to initialize the association between the books. Well, that actually means that in the result set, we now, because of this part here, only have book information where the ID attribute or ID column of the book is 2. That means we are losing book 3, 4, and 1. We are filtering them out by this part here. If we want to get all the authors who have written book 2 with a fully initialized list of their books, we need 2 join clauses. We need a normal left join for the where clause and a left join fetch to associate the books. Because when we are fetching the books with an initialized list of, when we fetch the authors with an initialized list of their books, we want to get all the books they have written, not just the book with ID 2. And because of that, we need to separate these two things. And if we then take a look at the SQL statement, we also see here that we have 2 joins from the author to, well, from the author to the book author and then to the book, and the same down here. The first one, the book 2, gets then used in the where clause and limits the actual result. And yes, this query down here is more complex and slower than the previous one. I totally agree, and I know that this always causes discussions. But I hope we all agree that the result of the first query is just plain wrong. I mean, we've got the authors with a fully we requested the authors with a fully initialized list of their books, and we don't get a fully initialized list of books. We might even run into the situation that at some point Hibernate thinks, okay, we now need to replicate the changes that we made on our entity objects back to the database, and in the worst case, we will lose data because we didn't select all the books that were written by the author. So here it's really important that we use 2 join clauses and don't use a left join fetch clause for something that we use in the where clause. If you're using JPA's criteria API, the first statement is not possible. There we have separate interfaces for a join fetch and for a join, and that's a good thing. With JPQL, well, you saw it up here, you could use that one in the where clause. And as you saw, that creates wrong results. I would actually prefer if Hibernate would throw an exception there and complain about in an invalid JPQA statement. Let's take an example. Let's take a look at another example that creates inconsistent or wrong results. Here, I'm using a JPQA statement to update records in my database. That's actually a great approach if you need to perform a mass update, if you have lots of records that you need to change. With SQL, you would always do it like this. With Hibernate and all other object relational mappers, most developers say, okay, we just select all the authors that we need to change, and then we call the setter method to actually change the attribute value of that entity object, but that resides in an SQL update statement for each and every entity object that you changed. So if you're fetching 100 entities and change their first name, then you trigger 100 SQL update statements, which will have a horrible performance. You can take this approach with the JPQL update statement to avoid that. Hibernate generates, and you can see that here. Hibernate generates an SQL update statement similar to the one that we would write ourselves. But that one has a few pitfalls. This statement here is just sent to the database. It doesn't affect our first level cache. And Hibernate doesn't know which entities are affected by this update statement. So if we fetched all authors, or just a few of them, before we perform the update statement, then Hibernate has a copy of these author objects in our actual persistence context of first level cache. Then we update it in the database. And well, as you can see in the log output, where the update statement was supposed to change first and last name to uppercase. In the log messages that I wrote after we executed the update, you can clearly see the first and last name are not in uppercase, even though we selected all the authors here again. So what happened? Hibernate fetched the authors from the database, created entity objects, which are now part of our actual persistence context. Then we send an update statement to the database. That one doesn't affect the current persistence context or the entity objects that are in it. Then we execute another query that gets the same objects. And we can clearly see in our log statements that Hibernate executed that query. But when Hibernate gets the result for that query, it iterates through the result set, checks, okay, here we have an entity, a reference to an author entity with ID 1. And before Hibernate uses the data returned in the result set, it goes to the first level cache, which is your persistence context, and checks, well, is there actually already an author entity object with ID 1? Because it has to ensure that there's only one object representation for each record in the database. We already fetched the authors up here. So when we are fetching them again down here, Hibernate says, yeah, there's already one in the persistence context. I can ignore that record from the result set. Unfortunately, that result contained the change that we performed here, and we don't see it until we commit our transaction and then also clear our current persistence context. So in any following transaction, we would see these changes within the current. We don't see it. You can avoid that by calling a clear on your entity manager. That removes all the objects from the persistence context. But before you do that, please always, and I mean absolutely always, perform a flush. Because if you tell Hibernate to clear the persistence context, Hibernate does exactly that. It clears the persistence context. It removes all references to managed entity objects. None of them will be managed afterwards. And it doesn't check if any of these entity objects are dirty. Or which means it doesn't check if you performed any changes on these entity objects. So if in between here and the clear, we don't have a flush and we called any setter methods on the entity objects, then that change will never be persisted in the database. And I had to analyze these kind of things for a few customers in the past. Believe me, it's a horrible error scenario. You get a description like, yeah, well, when I do this in the front end, then it looks like everything works fine. But out of this long list of changes that we did, every now and then some don't get persisted. It looks like we are losing some, and I don't know which ones. Yeah, and then you start digging and searching, and at some point you probably find a clear without a flush, and you just ran into the situation that some parts of your business logic triggered a flush, which wrote a few of the changes to the database, but there were some that were executed between or performed between the last flush and the call of the clear, and you just lose them without any warning or anything. So better be careful about that. Another thing that I want to show you that you can use to create inconsistent data, and actually you lose some of the operations that you thought you performed, happens when we are working with bidirectional associations. So here I fetch the author with ID 1 and the book with ID 1, and then I want to remove the book from the list of books that the author has written. If we take a look at our author entity, we see that we have a many-to-many association here, and this is the referencing side. This one references the author's attribute of the book, which defines our association. Okay, if I now go here and remove the book from the list of books written by that author and run the test case, take a look at the output, then I would usually expect that we remove a record from the author books table. No, book author table, right? I mean, we're removing an association. Well, here we have a select, another select, a select, and another select, where we are only reading data. The change that we did here was never persisted in the database because we only updated the referencing side of the association. Take a look at the log output, then we can see that Max Mustermann no longer wrote book 1, but book 1 was still written by Max Mustermann. And that is within this current session. But the removal of this association was never performed on the database. So here we have two issues. First of all, our author and our book object are no longer in sync. The book has an author in its list of authors that for which the author doesn't have the book in its list of written books. So we just updated one end of it. And we also lost the and it also didn't persist the change on the database. It gets better if we remove the author from the list of authors of the book, because the book has the models the association. That's the owning side of the association. So if we do it like this, then we have the delete operation here. We remove the book author entry, but we still have the issue that our two objects are no longer in sync. Max Mustermann still thinks that he wrote book 1, but book 1 no longer has an author. So until the end of our transaction, we have an inconsistent state. So we always need to make sure that we remove or manage the association. That's the case for all operations on both ends of the bidirectional association. That means you either need to do these two things each and every time you change something on the association, or make life a little bit easier and you provide these utility methods here on the book in this case that update both ends of the association, here for an add, there for a remove. And then you can be sure that that your state stays consistent and that you persist the changes in the database. Okay. The last thing that I want to show you to create inconsistencies, or to make it at least look like we have some inconsistencies, is the open session in view pattern, or we should better call it an anti-pattern, because it really is. Unfortunately, Spring Data or Spring activates it by default because it makes it much easier to implement a front end if you're able to fetch lazily initialized associations in the front end. That's the whole idea of the open session in view anti-pattern. You open the Hibernate session in your view layer, then you have the business layer that starts the transaction, performs all the business logic, and then closes the transaction. And when you then return the entity objects to your view layer, you can still initialize associations in that view layer. That has two issues. First of all, yeah, Aaron, you're right. It's Spring Boot which activates open session in view by default. And then that's actually a really bad thing. Because for two reasons, as you will see when we take a look at the log output here, you can cause inconsistencies by doing this because you're losing your the checks and guarantees of your actual transaction. And the second thing is it increases the load on the database because when you initialize the association in your view layer, we are opening up a new transaction, sending the statement and closing the transaction directly after we retrieve the result. And each of these transactions is actually a pretty expensive operation on the database because it needs to write everything that happened within the transaction into its logs and so on. So better avoid that in general. And as you will see here, you can create inconsistencies if you're really unlucky. So here I select the authors and I count the number of books that an author has written. I do that here. I get my author and the book count, and I use that down here in my log messages. So on the first one, I write the first and last name of the author and the number of books that person has written. And then I use the situation that my entity manager is still open, which is the main idea of the open session in view pattern, to access the books association, which I didn't fetch up here in my query. So this is something that at the beginning of this session caused a lazy initialization exception. Because we kept the entity manager open, we will not have a lazy initialization exception, but we will trigger another query within a separate transaction to get the books. Unfortunately, the parallel transaction that we started here removes a book author-book association. So you can see here the message that author Max Mustermann wrote 3 books. These are book 2 and book 3. These are only 2 books, and up here we say it's 3 books. Most users will not be too happy about these messages, or if we wrote somewhere that there are 3 books for the author, and below that we have a table with just 2 books. And well, all of that happens because we are losing the encapsulating transaction here. Please avoid the open session in view pattern. Make sure that you initialize everything up here. So we would do a join fetch to the books up there. And then we can also move the other way around. We can move the close to commit. Oh, what did I do? Oh, I need to add the book to my group by clause. Okay. Yeah, it's getting late. I don't know how to write JPQA statements. What did I do here? Authors must appear in the goodbye clause. Okay, let's do it differently. Remove that one. And our long book count is now a.get books size, because we want to print them out down here anyways. So we already fetched the full list of books. Oh, come on. Last try. That doesn't work. Then I'm pretty sure all of you already saw how the correct statement should look like. And okay. It's 7:30 after a long day. I'm obviously no longer able to write a meaningful or a correct JPQA statement. I think you get the idea. We are now joint fetching the association from the authors to the books, and we are now making sure that the association that we are using in our log messages are fully initialized, so that we can then close the session after our business logic was completed, and in the view layer, which I here simulate with 2 simple log messages, then just works on plain Java objects without any additional lazy fetching. Okay, so let's summarize this part real quick. So you should always make sure to use separate join and join fetch clauses in your queries. Join fetch clauses are just meant to initialize associations, not to be used in any where clause. You always need to make sure to remember that you are using caches, even if you don't activate any cache in your application. You always use the first level cache, which is your persistence context. If you're working with bidirectional associations, you always need to update both ends, and please avoid the open session impure anti-pattern. Okay, let's quickly lose some data, and for that I've prepared two examples here, and then we can answer more questions if you'd like to. You probably remember that I talked about a call of an entity manager clear. And then I said that you might lose changes if you clear without performing any flushes before that. So if you're implementing mass operations, so let's say we want to update all the books in our database and set the title to uppercase, then you could use a JPQL update statement, or you could implement it using entity objects. That's what I did here. So I wrote this query that gets all the books, and at some point I recognized, well, actually we have quite a lot of books in our database. So fetching all of them in one go is not a great idea. We better use pagination, fetch a bunch of books, iterate through them, change the title. Well, and then we at some point need to clear up our persistence context, because otherwise the garbage collector will not be able to remove the books, the book objects, because Hibernate is keeping a reference on it. And Well, as you can see, we are selecting here our books in multiple batches. Also updating 2 books, which are the books down here. But we haven't updated the first 10 books. And the reason for that is that we did a clear without a flush. Clear just removes the objects from the persistence context, which means Hibernate doesn't have a reference to them when it performs the next dirty check, which means Hibernate doesn't recognize that we made any changes on them and didn't create an update statement. If we flush before we clear, and you can see here that we now have performed all the updates that we expected. And here you can see lots of update statements in the log, 1 for each book. Because now we are iterating through the books in pages of, in this case, 5. And after we completed the update, we flush of 1 batch, we flush and clear. Okay, last thing I want to show you tonight is cascading and how risky it actually is. So let's say we have our author and our book entity. And when we remove an author, we also want to remove the books that the author has written. So we could say we activate cascading on the many-to-many association. And well, if we have a book that we delete and the book isn't written by, and the book is the only book of an author, we also want to remove the author. So we activate the cascading here. Well, that is a common thing that you can find in some discussions and on some forums on the internet, and it's actually a really bad idea. So you already see it here. We have 51 JDBC statements. So what happened here? We actually removed our full database. Where does it start? So we got a book and the authors of that book, and fetch more authors and more books and so on before Hibernate triggers the delete statements. It first removes a few records from the book author table, which is the association table. And then it starts deleting books 1 by 1 and authors, and then another book, another author, another book, in this case 2 books. So what happens here? Well, I've removed 1 author. On the author, I told Hibernate that I want to cascade all operations, which includes remove operations, which means that we are cascading the remove operation from the author to the books. So now we're removing all books for that author. To do that, Hibernate gets the books and finds this association here, which also has a cascade type all on it, which means that for each book, Hibernate now removes the authors. And Hibernate removes all authors of that book, even if they wrote other books. To make it even worse, because that book has a cascade type all on the many-to-many association, Hibernate gets the authors of that book and removes all of their books. And if you have a situation like I designed here in my test database, we get the first author, author A. And if we take a look at the SQL statement, then we can see that author 1 wrote 2 books, book 1 and book 2. And book 2 was also written by author 2. So we now remove author 1, cascade the remove operation to book 1 and 2. For each of these books, we cascade the remove operation to their authors, which means we get all of the authors who have written that book and remove all of them. And for each of these authors, we again cascade the remove operation to the books. So congratulations, you clean up your whole database. Well, you might now think, well, that's actually pretty simple to fix. You just use a cascade operation on one of the two entities. And well, that at least improves the situation. But it still is probably not what you expected. So let's take a look at the authors, at the book that author with ID 2 has written. So if take a look at this code here, we remove author 1. And we log out the books of author 2 before we do that and after that. So before we delete our author 1, we have the books 1 to 12 in our database. And author 2 wrote book 2, 3, and 4. And now we remove author 1, and we can see here that we remove a record from the book author, another record from the book author, and another one. And then we remove 3 books. And afterwards, we see we only have book 4 till 12 in our database. We removed book 1, 2, and 3. Unfortunately, we removed the book even though author 2 was a co-author of these books. So by cascading the remove operation from the author to the books, we remove all of the books, even if they have more, even if they were written together with other authors. And I'm pretty sure that these authors wouldn't be too happy if we would do that in a real bookstore and they are no longer able to sell their books. So when you start cascading, or when you start thinking about cascading, please be very careful about using it. Cascading is thought to be used for parent-child associations. Basically in situations where the child depends on the parent. A typical example would be an order position that belongs to an order. There, it makes total sense to cascade the operation from the order to the order position. In all other situations, you should avoid cascading. Otherwise, you run into situations like this, where you remove way too much data. In this case, where you remove all the books written by the author, even though they were written together with other authors and should probably stay in the database. Okay, so luckily there are not too many things you can do with Hibernate that actually cause you to lose data. But using a clear without a flush is unfortunately a recurrent candidate for data loss, and the same for cascade remove, especially on many-to-many associations, because there you usually don't have a typical parent-child association for which it makes sense to use cascading. And there you have independent objects that are just connected with each other. And there you should better implement the cascading yourself, because then you can add additional checks. Like in that case, you could check if there is another author for that book or not before you remove it. Okay, that's it for today. I will pick a few questions from the chat. And there's at least one by Chris. If you have any questions, feel free to ask them in the chat or to unmute yourself in a few seconds. But for now, I want to take the chance to tell you really quick about the tool that I will launch tomorrow. It's called Perf Tester, and it helps you with Hibernate to find a performance issue in your persistence layer, like the n+1 select issue that we had before, like the situation with too many join fetch clauses. With Perf Tester, I'm hooking into several points in Hibernate, collecting actual statistics about what's going on in your current use case, analyze it, and tell you about the performance issues that you currently have, which has the main advantage that we can find performance issues even on a small test database, because I can see that you initialize an association, for example, in 80 to 100% of the cases you use a specific entity and similar things. That means you don't need a huge production-like database to find performance issues. And you also don't get all the theoretical issues that you would get with a static code analysis, because we are doing a live analysis of what's actually going on in your application. And by doing that, you then get all the information you need to actually fix these problems. Because I'm not only telling you, yeah, there's somewhere an n+1 select issue in your code. That is something that you would easily find with Hibernate standard statistics yourself. I exactly point you to the point in your code where you fetch the entities for which you caused the n+1 issue, and the point in your code where the actual issue really occurs. And then you have all the information that you need to fix it. Okay. So Chris asked, Tom, I like your setup for Java in VS Code. What extensions are you using? It's just a VS Code with the Java extension. And it works reasonably well. So I like the look and feel, especially for presentations like this. It's very clean. Seems to have a few issues with really complex projects. So multi-module Maven projects that are really huge. That's something that you might take an extra look at. But in general, yeah, it works great. I like the look and feel. Yeah. Okay, any other questions about Hibernate or JPA or other Java persistence topics?
I would have at least one. You mentioned once entity graphs for fetching entities. Could you explain it? Is it better to use entity graphs or left joins, join fetch to populate the entity?
Yeah. Well, let's get in the IDE and take a quick look at an entity graph. So up, where is it? Here, we have a left join fetch clause from author to books. So the good thing about this left join fetch clause here is that it is in our query. It's really easy to use. It's easy to write. But it also has the downside that we are now have a query that also defines the fetching behavior. So that means we can't use the same query with different fetching behavior. If we need that, then we could use a named entity graph, for example. So we could do named entity graph, name, author, books, and then we have one or more attributes nodes, named attribute node, and that one is books. So now we have a graph definition that tells Hibernate to initialize the books element down here when it is used together with the query. And we could use that either with the entity manager find or with a query. We could use it. Single result. No. We first need query get entity graph. That thing was called author books. That's our graph. And then we can do set hint query graph graph. Yeah, and now it's called, I think, graph semantics. Yeah. Graph semantic fetch JPA hint name. Get single result. So the result of this is exactly the same as the result of that. There's no difference. If I now run the test, you will see that it works in exactly the same way as what I did before. So we have all the information to answer or to write the log message, and we have the left outer joins up here. The main difference is that we now separate the graph definition from the query itself. That on one hand enables us to execute the same query with multiple graph definitions, which can be nice if we actually need it, but at the same time, it also makes it a little bit harder to read and to find out what we are actually fetching when we call the get single result method here. So if I have this code block, then I exactly know what's going on. I know that I would select the author entity, that I would join all the books, and that I would get the author with all its books. Down here, well, I'm not so sure. Hopefully I used a good name for my entity graph. And hopefully nobody changed the actual fetching behavior defined by the graph after we named it in a way that it was actually telling us what it does. So because the second block is harder to understand and to read, and actually, well, it also requires more code. I have an annotation here. I need to get the entity graph. I need to set it as a hint. Definitely more work than that small join fetch clause. Because of all of that, I, in general, prefer left join fetch clauses in my queries. But if I'm in the situation that I have a complex query that I need to execute with different fetching behaviors, then I'm using either a named entity graph or the entity graph API. So you could also do create entity graph on the author class, and then either add attribute nodes or add subgraph to then fetch the books. So I could use that. Instead of the named entity graph as well. Can't I? Okay, so I move that up there. That is my graph. Yes. So this approach here, using the entity graph API, would be a good thing if you are using the criteria API, for example, to dynamically build your query at runtime, for example, based on user input. We used that in several projects when we had a complex search dialog in the front end where the user was able to search on different fields of our domain objects and then check a few boxes to request additional information. Then we used this approach here to dynamically build the whole query and the fetching behavior. This one here, the named entity graph, would be a good approach if you have a static graph definition that you want to use with multiple queries, or where you have one query with multiple graph definitions that you want to mix and match, basically. And this one up here is the best approach for all the standard situations where you just have one query with one fetching behavior. So in my projects, I would say I use this up here in somewhere between 80 and 90% of the cases. And then the graph API for these complex dynamic stuff, and then in a few use cases, the static named entity graphs.
Thanks a lot.
Any other questions?
If no one kicks in, I still have one last question. You mentioned that using lazy fetches should be avoided. Using eager fetch should be avoided, and lazy fetch preferable. Could you think out of a good use cases for eager fetch for parent-child relation or many-to-many relations? Not really.
No, not really. So the only situation in which eager fetching would actually be a good thing is if all use cases of your application need the parent object together with an initialized list of child objects. And I mean all of your use cases that fetch the parent object. And as soon as you have more than 3 or 4 use cases that you implement in your application, that will not be the case. So eager fetching is a code smell. And please keep in mind that to-one associations are fetched eager by default. So there you would need to set the lazy fetching in your mapping code. And I recommend doing that for all associations that you add to your project. If you have already a huge domain model where you didn't do that, then I recommend to analyze your use cases and pay close attention to the associations that you fetch eagerly there and check if the additional queries actually create a performance issue or not. So it's definitely an overhead, and it would be better to fetch them lazily. The question is it actually worth it to refactor the code and switch to lazy loading? Because if the eager fetching just triggers 4 or 5 additional statements, then from a performance point of view, it will probably not make a real difference, or at least not a difference that the user will recognize. But as a general performance recommendation, I would say you always use fetch type lazy. And these join fetch clauses to fetch the association when you actually need it. Because by doing this, you get the best of both approaches. You basically get a form of eager fetching of the association. So you get the author with the initialized list of books. But the important difference to fetch type eager is that here you had a look at your use case and you decide, okay, I need the books of this author. And only in that case, Hibernate initializes the list of books. If you would set the fetch type to eager, then we would get into this situation that we had at the beginning of today's talk, where I ran this code here, where we don't use the books association, and Hibernate fetched it anyways, because we set the fetch type to eager. And that is just an unnecessary overhead that slows down the application.